Hello everyone and welcome to my channel. In the previous video, we saw what symbolic prompting is. It's going beyond asking, it is about instructing with rules. But there is something deeper. Most people interact with artificial intelligence using lines of text, asking questions and expecting the best answer. The problem is that when there are complex tasks, artificial intelligence can suffer from hallucinations, or it may not remember what was asked, or even give you an answer that has nothing to do with what you are asking. What happens between one prompt and the next? Artificial intelligence doesn't live in a vacuum. Each prompt transforms something. That something is called a state. You have a light switch that is off. If a hand presses it, then the lights turn on. The same thing happens. A state machine is any system that has a current state, receive an input, change to a new state, and process an output. A traffic light, an automatic door, your coffee maker, they are all state machines, and your prompt too. In computing, an state machine is a model that can be in exactly one state at a time from limited number of states. Think of an ATM. State waiting for car, state asking for PIN, state processing transaction. The ATM cannot give you money. It has not first gone through the asking for PIN state. In symbolic prompting, we apply this same logic rigidity so that artificial intelligence doesn't script critical process. Artificial intelligence doesn't respond, it maintains a state. There is an expected output, a simple explanation. If we change the state, the behavior changes. It is still the same model, but with a different state, different behavior, yet it's begin control. When we have a prompt where we'll tell it that it's a math teacher, it has flow of rules, where it flows state by state, such as start class, explain, give examples, ask questions, give feedback. We can define more state. Here, you are the memory administrator. Artificial intelligence only reads what you write to it. Here, the state is explicit. The artificial intelligence doesn't need to infer whether the light is on or is off. You clearly define it for them. Each prompt is an state machine cycle. You read the previous state and apply the input, calculate the new state, and send it back. We define a state, which is used as input. The model processes the rule and returns a new state to us. This is a state machine, and this is symbolic prompting. If you want the artificial intelligence to remember, you must send it the state in every prompt. Same state plus same input equals very high probability of same output. If the state is explicit, we achieve almost deterministic behavior. If the artificial intelligence gave an incorrect response in a well-structured flow, most of the time the error is how we define the rules or the state, not in whim of the machines. As mentioned earlier, in a prompt using natural language, the artificial intelligence can give you different response. Using symbolic prompting, you send it the same prompt multiple times and you will get consistent and predictable response. Remember, in every interaction with artificial intelligence, it's a state machine. You are one who must maintain and send the state. Explicit state equal deterministic behavior. Now that you understand what prompt is state plus role, the next class will reveal the deep secret, the differentiate between normal tokens and atomic tokens. But how do you get the artificial intelligence to differentiate between informative text and executable text? The answer lies in tokens. In the next class, they differentiate between a normal token and atomic token. If you like the video, don't forget to like the icon and subscribe to my channel. I see you in the next video.